Abdullah?
Yes, ma'am.
Okay. So what it is given here, the sample mean and the population mean. Now we will deal with problems where mean will be given. You have done the calculation of mean in your previous semester. Mean simply means the average. Okay, average of a set of values. You will have a set of value, and if you take the total of that value, divide it by the number of the values, that means number of items, then you get the mean of that list of the values, right? That way you calculated mean. So here now we will operate with the means and then test for their significance. So here in this problem, sample mean, then population mean, these things will be given. I hope you know the difference between population and sample. Population is a total area from in which you are doing the research, and it is not possible for you to select the entire population, because there can be, for certain research, the numbers can be huge. So in those cases, what you do is you select a sample. There are different ways of selecting the sample. Based on those ways, I'll teach you the ways also after the problems. Okay, so based on those sampling techniques, you need to choose a sample, and then you say that the sample represent the population. Whatever result you get of the sample, you will say that this sample's result will exactly match with the population's result. Not even if it is not exactly, it should match more than 50%, like that. Okay, so you don't deal with the entire population, but rather you select a particular sample and then you test the details of that sample. That way you proceed, and that is how a sample represent a population. So in these problems, sample mean x bar, you may have to calculate sometime, or it will be directly given. Then there will be population mean, which is mu. This symbol is called mu. I think you can see my arrow on the screen. So this symbol, no, population mean, and then one symbol is written, which looks like an inverted H. So this sign means mu. This mu signifies the population's mean. Okay. So if you have the information of these two things, then you will calculate the value of the Z statistic. And here also you will have to calculate the standard error. So there are certain rules also, the formula also for calculating the standard error. This table no need to write. Okay, this is the same as the previous one. At 5% level of significance, what is the critical region? Critical region is when we are equating the proportion, when we are equating the mean, then it will be mod z greater or equals to 1.96. That means if you get the calculated value of z as a greater than 1.96 at 5% level, then you will reject the null hypothesis. These rejection rules are for what? These rules are for only H naught. And if you reject H naught, you have to accept the alternative hypothesis, that is H1. And vice versa. If you accept H naught, then you will have to reject the alternative hypothesis. It's like that. Then at 1% level of significance, Z value should be greater or equals to 2.58. And when we are using the greater than symbol for any, it depends on the information provided in the problem. Okay, so if we are testing with a greater than symbol, then the value critical region for Z will be greater or equals to 1.645 at 5% level of significance. So if you get the calculated value of Z, which is more than 1.645, then you will reject the null hypothesis and thus accept the alternative hypothesis. And at 1%, if it is greater or equals to 2.33, then you will reject the null hypothesis. And third one, if you are using the less than symbol, depending on the information provided in the question, then you have to check whether the value of Z, calculated Z, is less or equals to minus 1.645. Okay, so If it is less than minus 1.645, then you reject the null hypothesis. Otherwise, accept. And at 1% level of significance, you will have to check whether the value of z is less or equals to minus 2.33. If it is less, then you will reject the null hypothesis. Okay. Then in some problems, you will see that you are asked to calculate the confidence limits also. So in confidence limits, you have to use both the symbol plus and minus. So if you are asked to find the confidence limit as 95%, then you will use this formula. You can write this formula in your copy. Table no need to write. You will have to remember these numbers, that at 5% level what are the values, 1% level what are the values. You just remember the values, but this formula you write, it will be required for when you will solve the sum. So write down this formula. Confidence limits for the population proportion, um, not proportion, huh? It will be mean. Confidence limits for the population mean mu r, like that you write. Don't write proportion, write mean. Confidence limits for the population mean mu r, for the population mean mu r, then you write 95% confidence limits equals to 95% confidence limits equals to x bar. What is x bar? X bar is the sample mean, right? So you write 95% confidence limits equals to 95% confidence limits means 5% level of significance, and 99% confidence limits means 1% level of significance. Okay. So 95% confidence limits, did you write this? X bar plus minus 1.96. In bracket you write SE of X bar. SE of X bar. SE means standard error. So what you wrote? 95% confidence limits equals to X bar plus minus 1.96. In bracket you write standard error of X bar. Bracket close. Then you write 99% confidence limits. 99% confidence limits equals to x plus minus 2.58 x, x bar plus minus 2.58 into, in bracket you will write standard error of x bar. Standard error of x bar. Bracket close. Then next line you write where SE of x bar equals to, where SE of x bar equals to, where SE of x bar equals to sigma. This symbol is called sigma. Okay. This symbol is called sigma. This looks like a little bit of 6, but the top portion of 6 will have to be bent a bit. So you write this symbol and this is called sigma divided by root over of n. N is the sample size. Sigma is the standard deviation. You write that. Okay, you write where AC of x bar equals to sigma by root over n. Then you write if the population SD, if the population SD, SD means what, you know? It means standard deviation. This also you learned the calculation of standard deviation in your previous semester. I hope you remember. So you write if the population standard deviation sigma, sigma is actually the population standard deviation. Okay. So if the population standard deviation sigma is not known, if it is not given in the question, it is not known. Okay, if the population standard deviation sigma is not known, comma, it is replaced by the it is replaced by the sample standard deviation S. It is replaced by the sample standard deviation S. Okay, have you understood? Sigma in the standard error you are writing, in the formula of standard error you are writing sigma divided by root over n. N will always be known to you. This is the sample size, and sigma is the population standard deviation. If it is not given, then you can also use the sample standard deviation for calculating the standard error of x bar. Understood till this much?
Yes, ma'am.
Okay. So let us move ahead. So write down another formula. Today first we will write both the formula, then we will solve the sum. Okay, next type of testing is test for equality of two means. Just like proportion, we first tested single proportion, then we equality of two proportions were tested. Here also first we will do the test for a single mean. This is for test for a specified mean, and specified mean a single mean. Okay, and fourth type, write down test for equality of two means. Test for equality of two means. Test for equality of two means. Okay. Then this lines you can write. Suppose we have two independent random samples. Write down this line. Suppose we have two independent random samples. Suppose we have two independent random samples of large size. Suppose we have two independent random samples of large size n1 and n2, n1 and n2 from two populations, and the sample means are x1 bar and x2 bar respectively. X1 bar, this line at the top is called a bar, x1 bar and x2 bar respectively. Full stop. It is required to test whether the two populations it is required to test whether the two populations have the same means. Whether the two populations have the same means. Okay. Previously in the second type we were testing the proportions P1 equals to P2. Now here we will test x1 bar equals to x2 bar, like that. We test the population 1, so we test mu1 bar mu1 equals to mu2. Mu1 and mu2 are the population's means. Okay, and x1 bar and x2 bar are the sample means. So after this you write the standard error of the difference of means. You write this line, the standard error of the difference of means The standard error of the difference of means x1 bar minus x2 bar is, to write this formula number 14.7.8, you write down SE equals to big root over, under this big root over you write sigma 1 square by n1 plus sigma 2 square by n2. You can follow the arrow where I am. Standard error equals to big root over you will write, and under the root over you will write sigma 1 square by n1, sigma 1 square by n1 plus sigma 2 square by n2. Sigma 1 square by n1 plus sigma 2 square by n2. Okay. Then you will write where sigma 1 and sigma 2 are the standard deviations in the two populations. Where sigma 1 and sigma 2 are the standard deviations in the two populations. Are the standard deviations in the two populations. Full stop. In order to test the null hypothesis, that the means are equal, in order to test the null hypothesis that the means are equal, then write H naught in bracket, we now write mu1 equals to mu2. H naught mu1 equals to mu2 in bracket. In order to test the null hypothesis that the means are equal, H naught mu1 equals to mu2, we use the test statistic, then write we use the test statistic, then write the formula number 14.7.9. It will not be SE, okay, it will be Z. Z equals to, in the numerator you will write x1 bar minus x2 bar divided by SE. Z equals to 14.7.9 will be Z equals to x1 bar minus x2 bar divided by SE. This SE can be calculated by using the former formula, which is 14.7.8. Using that formula, you will calculate the standard error, and then in the test statistic, you will use that calculated value of SE, that is standard error. So the formula of Z will be x1 bar minus x2 bar divided by SE. Then you write, you know that how to take the alternative hypothesis. It depends on the information whether it will be not equals to or greater than or less than. So no need to write this portion. Directly you write the confidence limits. Confidence limits for mu1 minus mu2 are confidence limits for mu1 minus mu2 are confidence limits for mu1 minus mu2 are, then you write this too. 95% confidence limits equals to x1 bar minus x2 bar. This will be in bracket. Then you write plus minus 1.96 standard error. And 99% confidence limits will be x1 bar minus x2 bar, this will be in bracket, plus minus 2.58 into SE. Right? Only the confidence limits. From page 562, write the confidence limits only. Okay, written till 14.7.10. Have you all written till 14.7.10? Done till 14.7.10, all of you? क्लास হচ্ছে চুপ বাপা খাবে yes could you write or you missed anything then tell me I will scroll the screen then if you have missed anything no one speaks why
Yes,
Deepa
ma'am.
Reena written okay Reena
Yes. Yes, ma'am.
Pema are you writing Sheetal Bikram okay I hope you're writing so these are the formula okay then let us do one sum today and rest of it we'll do tomorrow okay you can write the problem you can write the question later on I'll just read it and listen to me then solve the sum after that after the class you can finish writing the question okay I'm talking about example 14.26 it says that a sample of 400 male students all of you listening no all of you are listening to me so it
Yes, ma'am.
says okay. It says a sample of 400 male students is found to have a mean height of 171.38 centimeters. Okay. So the sample is 400 and it says that the mean height of the sample is 171.38. Can it be reasonably regarded as a sample from a large population with mean height 17.17 centimeters. It will not be 17, it will be 171. It will be 171.17 centimeters in bracket 1. Okay, you will rectify it while writing. It will be 171.17 centimeters and standard deviation 3.30 centimeters. Okay. All right. So we have details about the sample number and sample mean. We know. So x bar we know and the n we know. Now we have to test whether this sample can be stated as a population which has a mean height of 171.17 and standard deviation of 3.30 centimeters. Okay, it's like something, when you select a sample from a particular population and you want to prove that this sample represents the population because otherwise your test will not be correct, no? Your test will not provide practical results. So first you have to test whether the sample which you have selected really represent the population or not. So in order to test that, this test can be applied. Okay, just a minute. Okay, so you have to first test whether this sample really represent the population or not, and then only you can say that your selection of the sample is correct. So you write down this line. In solution portion, you write, we assume that the sample really comes from a large population. You write this line till alternative hypothesis, you write. In solution part, you write, we assume. So you will write, we assume that the sample really comes from a large population with mean 171.17 centimeters and standard deviation 3.30 centimeters. So null hypothesis is null hypothesis is, you write this one, H naught in bracket, you will write mu equals to 171.17. H naught mu equals to 171.17. You will not write sigma equals to 3.30, okay? You will only write mu equals to 171.17. Bracket close. Then write the alternative hypothesis also. Alternative hypothesis is that the sample does not come from such a population. Here no information as such, like greater than or less than, more or less is given. So simply we will write not equals to. Okay. বাবাই ফ্যানটা চালিয়ে দাও তো, ফ্যানটা চালিয়ে দাও। হুম। Okay, so simply you will write H1. You simply write not equals to. Okay. Okay. Now calculation of this Z is your homework. Calculation of this Z is your homework. Okay. You all can solve this. If you are following properly the previous classes also, then this today's class also, you will be able to calculate, because simply everything is given. X1 bar is given 171.38, that is the sample mean is given. Then mu naught also you know, which is 171.17. You can write mu also, no need to write mu naught. Formula was what? If you are getting confused with observed and expected, you can simply use this formula, x bar minus mu naught divided by standard error of x bar. So first you will calculate the value of standard error of x bar. After that, you will put that value in the denominator and put in the numerator the observed value or x bar, which is 171.38, and expected value, that means the population one, population mean, because we expect that the sample mean should represent the population mean. That's why that is our expected value. So 171.17 you will write, then you will divide it by the standard error, you will get some value, then you will check for 5% level both tail test. That means the first one where alternative hypothesis is a not equals to sign. Okay, so finish this sum. All right, finish this sum and tell me tomorrow whether you could solve it or not. I will ask. Just a minute. I'm taking attendance. Do not leave now. Till that time, you can keep on solving if you want. Vikram, Deepa, Pema, Prajwal. Vikram, Deepa, Pema, Prajwal. Vikram, Deepa, Pema, Prajwal, Prayas, Reena, Sheetal, Yogesh. Prayas, Prayas, Reena, Sheetal, and Yogesh. Okay. All right, your attendance is given. You can leave the class and please finish this sum. I will ask tomorrow whether I may ask you to show also what you have done. Okay. So you can leave the meeting. See you tomorrow.